Okay. Finishing up chapter 3, looking at hypothesis testing, differences between two means, or the two-sample t-test. So, we want to see if there's a difference in price people would offer a friend rather than a stranger. Here's our statistics data. Here is our table on that data. Let's go through some assumptions first. Independent groups. Can we assume that what you would offer a friend is independent from what you would offer a stranger?
Yeah.
Yeah. So that one passes. There we go. So that one's cool. Okay. Independent assumption. Can we assume that each person we price, whether they are a friend or a stranger, is independent?
Yes.
Okay. Randomization. We can throw some randomization in there. So, how will we randomize this? Well, I mean, you would describe a person, they're either your friend or your stranger, I suppose. And looking at the table here, would we say there's a nearly normal model? I mean, this one's okay.
It's okay.
Uniformal, symmetrical. This one, kind of borderline.
Yeah.
A little bit skewed over here, but I think this would balance out this. It would make it, let's just say it's close enough. For the sake of this condition, we'll go ahead and make the assumption. Meaning, we'll have to justify why we assume this is normal, if somebody were to ask. Let's come up with our null hypothesis. So I want to say that there is a difference between friend and stranger. My null is going to be that that there is no difference, right? If I take my friend, subtract it with the stranger price, it's going to equal 0 with no difference. So what would be the alternative? If you were to subtract the price you charge a friend with the stranger, would you expect that difference to be greater than 0, less than 0, not equal to 0? What?
Not equal to 0.
Not equal to 0. So there is either a difference or there is not. Now, let's run that two-sample t-test. So we're going to go to our calculator, hit stats, go to test. Right here, two-sample t-test. So if it was just one sample, we would go to t-test. With 2, we have 2. So number 4. Hit enter. And then if we had data to put in, we would put in our L1 and R2, but in this case we have statistics. So it gives us our mean for the friend, the standard deviation, and the n value of 8. So this is why we're running a t-test, because notice my n value is pretty small, right? It's less than 30. Otherwise, we could run a z-test if we wanted to. And then it also gives me my statistics on my stranger data. Note, just quick observation. Quick observation. Looking at the means. Do you charge more for a friend than you do a stranger?
Nope.
Or the difference in price people would offer a friend.
You give him a discount.
Well, what does the data say? It says the friend's average is $281. A stranger's is $211.
That's
It's
weird.
a terrible friend.
I know, what kind of
I
friend?
don't think they're friends.
Don't know, but that's what they did. Maybe they owed their friend money, so they put it in with the price. I don't know. Here we go. My alternative is going to be not equal to, and not going to pull the data. And calculate. So based on the p-value, do you accept the null or reject the null? Reject the null. Why?
It's less than 0.0.
Yes, look how small it is. So we will reject the null hypothesis and conclude that people are more likely to offer a friend more than they did offer a stranger. So yep, we reject it. So same thing we've been doing with all the hypothesis testing, check our conditions, set up a null and alternative hypothesis. Only difference is we are going to 2-sample t-test because our sample size was so small. Otherwise, if this was greater than 30, like I mentioned, we could use a z-test.